Hello again. Hello again. So I've just time warped a little bit. I've left everything as it was. I just stuck with the Homan transfer because I was trying to think of why it worked first time here and if that might just been chance. Anyway, so I'm just skidding away. Like I haven't even aimed myself. I'm just doing manual time warp. So right now I'm on this lower kind of blue, sometimes green track, and here you can see the station. So after, about 2/3, 3/4 of a day, I'm catching up to the station, and that's because if you've tried to do rendezvous or looked at orbits in stock Kerbal, an orbit in a lower path closer to the Earth moves a little faster, and so I'm catching up. And so I was like a day behind, or I mean the opposite side of the world when we launched as the station, and now in a little under a day we're finally catching up to it, and we have very substantially different orbits. As you can actually see the period difference here. So let's see, my orbital period is just under an hour and a half, and the orbital period for them is like about 4 minutes longer. So they're fairly substantially different. 4 minutes may not seem like a long time to you, but considering we're both moving at about a little under 7.5 kilometers per second, 4 minutes, you cover a lot of distance in 4 minutes, and we're covering a lot more than them. So we're catching up. So we're obviously never going to match up with them, be at the same spot the way this is. So pretty soon, let's say when we're under, there we go, under an hour now. So we're getting close enough that if we, just like, imagine this is Earth and that's Mars, which is a bit further out. At some point we're kind of at the right positions relative to each other, that if I swing myself out towards it, if I phase between being down here and the arc it was showing you where we arc up to that altitude of orbit, then the distance that I close, I'll be just far enough behind it that, I'm below it, so I'm still moving at, covering distance faster, but as I approach it in altitude, I'm covering distance, slower and slower. And so there will be just a right point where if I make an acceleration forward, which I'm planning to do at the other side of this orbit, here I will let it, here I'll save. Sometimes the Homan transfer goes crazy. There we go. Homan transfer. Nope, calculated it about the same position. So this is a trick that I actually didn't know. Usually what I do is set myself up for kind of a phasing orbit. So that would be, right now, my whole orbit is below the station orbit entirely, right? Like if they're two circles and they never cross. So what I usually do is set it so that my peak is matching with, it would be 470. And so I could virtually see, it would tell me how far apart every time I come around, and my 470 matches its 470, and then I would see how far separated we are. And then if I warp it around one orbit, it would tell me how separate we are, and I could compare those two distances. And with that, I could calculate how, what's the difference. So let's say we were 3,000 kilometers apart, and then one more orbit around, and then we're 2,800 kilometers apart. So that means that's how much I'm going to be catching up, and I can do the division and figure out whether, how many orbits is going to take before I catch up. Or it could even be the opposite way, right? Each orbit I could be getting further and further away from it until we finally cycle all the way around. But in this case, I am catching up to it. So at this point here, we can see the maneuver node that it's set up for the Homan transfer. This is, again, a lot easier than it's ever been for me, so it really is a good video to do because I learned something. So node, set to node, and execute next node. Well, that's strange. For some reason it is, oh no, I must have set it up like pretty well timed, where the actual burn time is going to take about a minute, and we were about 30 seconds before the node when that happened. So now you can see my orbit is rising, 1 point of my orbit, because obviously this point here, the low point of my orbit, isn't going to get any higher due to this burn. And those numbers flip because that's just a convention that the lower one will always be showing first, periapsis by apoapsis, and then the engines are going to cut out when we hit 470 here, as foretold by the prophecies. There we go, MacJeb says, and indeed it is. And so now if you look, even stock tools will show that we are separated by a very tiny distance here. So here I turned on my RCS, and I'm fine-tuning this. So here I'm looking at it that way, but actually here, I would assume somewhere here, separation at closest approach. So I can just actually watch that number there, and I can fine-tune till that's as low as I can get it. So which direction do I burn in? Looks like 130 as low as it's... Oh, by doing this, I can get it slightly lower. Now, when you use your RCS, notice it's causing me to spin. I wasn't spinning like this before, so when I pulse this, it must mean that my center of mass isn't exactly, here's the bottom of the craft, here's the top. It's not perfectly in line with where those are. And the center of mass of your craft changes with time. Oh, I actually ended up making it worse. Yeah, that's good enough. 130 is plenty. I can see it at 130 meters, so sounds good. Get closer. See, sometimes this calculates things really crazily. So let me just turn all those off. So let's say match velocities at closest approach. That's actually not bad. So it's telling me about how much delta V I'm going to have to spend when I get there. Let's see, align planes. We're already aligned, so it says just a tiny correction. So sometimes I'll find that this gives you really crazy numbers, like if you clicked at get closer when you're not in the same planes or anywhere near each other. So you kind of have to use them in the right order. So first I used align planes, and I had my relative inclination relatively low, and then I made sure that my current orbit was complete all below, or you could also probably do the inverse where you're all above your destination orbit, for your target, and that told me how long I had to wait. So it was only quote unquote a day where we had to wait in orbit in order to catch up to relatively close to the station for this home and transfer. So now this number is going to keep getting smaller and smaller, and one downside of what we just did is that we're going to be meeting up on the dark side. So I'll hopefully be able to turn on a light on my craft, and when we actually do the docking, we'll probably have gone around far enough that we'll be in the light. So here my orbit's getting closer and closer. So just like when you try to go from Kerbin to Duna, or when you go from Earth to Mars, our orbits get closer and closer until I intercept its orbit. No, we're pretty darn close, and there we get I'm not sure why. So this says separation at closest is 127, and here it says 2.7, so who knows which one is right. But intercept, match velocities at closest approach. What about get closer? Well, that's not too bad either, actually. And that's... Well, let's do match at closest approach. So that just basically inverts the target velocity. So that's how fast I'm moving. So, now that you have something targeted and you're close to it, so I can see my orbit, I can see the surface, and I can see target. So if I point, towards the kind of yellowy green reticle, this will neutralize it. So estimated burn time, I'm curious if that's accurate, but let's find out. Since my service module engine is, no, so there we go. So it doesn't really estimate it. Oh no, it's about 30 seconds, okay. So about 15 seconds before we get to that node, I will want to, ooh, it almost choked there. So about here, I will now burn so that we are going about the same speed. So rather than it flying past us at closest approach, we'll be moving about the same. And then I can close this. And I already have some windows, some numbers set up in here. Now, I'm not sure offhand if this mod still exists or works, but one that seemed useful in the past was called Navy Fish. Let's see, lights on. Oh, I had the light on the whole time. Okay. And so Navy Fish kind of gave you a view so you could align. If you've seen older Bob Fitch videos, he used that all the time. It kind of gives you a way of seeing if you're aligned and your relative velocity and everything towards the craft that you're targeting. So are we still moving away? Yes. There we go. So, with this station as it is, I think I should be able to use just these tools. So usually in docking there's an active and a passive partner. So it means one of them is going to do all the maneuvering and the other one just has to station keep. It just has to stay in the same place. So usually, just to save kind of time and delta V in a docking situation like this, I would use both of them to kind of let's say right now the station is pointed not directly towards me. Well, I could go to the station and then point it towards me. But I'm not going to do that. First I'm going to get, say, within 50 meters or so, and then I'm going to set myself up to be parallel, or actually anti-parallel. So if you imagine an arrow pointing out of my docking port here and an arrow pointing out of the docking port there, I don't want them to point in parallel. I don't want the arrows to point right next to each other. I want them to be anti-parallel, so they point directly at each other. So once I get a bit closer, I will point us anti-parallel. So out here, it's going to show me time to closest approach, and that may seem like it's going to take 4 minutes to get, to cover this relatively small distance, but actually that is fairly ideal because I want to wait until we're kind of more out into the sun. There we go. So now we're getting some sunlight, and once I get closer, say within 50 meters or so, I'm going to stop us moving. Here, maybe I'll cheat a little bit because the closer we get, the more we save time. In practice, they're much more careful with their maneuvers with the space station and the approaching craft, but I'm saving time and probably not saving delta V, mostly just time and effort. Because see, these little thrusters, like as I'm trying to slow down, it's actually shooting out gases, and it's because I'm trying to slow down, it's shooting those gases towards my space station. So they don't want to do that in reality. Okay, so we're close enough, so I want to go anti-parallel. Now, MechJeb has that option. Target, I already still have it targeted, anti-parallel, then turn this on. So it's going to anti-align our docking ports. And MechJeb also does have an auto-docking tool. I find it doesn't work very well in real solar system unless you set stuff up quite a bit beforehand. And just with a little bit of practice, I found that I've still, I can still do it a bit more efficiently than it will, even when things are set up nicely. So I want to be backed up. So take a look at these numbers here. So it's X, Y, Z, X, Y, Z. Or Z, as I suppose is a more Canadian way to say it. There we go. So I want all these numbers to ultimately be relatively close to 0. So I want to tell it to calculate things from there. That's an Apollo docking as well. Okay. So first I'll just get these relatively close to 0. So that's how far away we are. Let's see. In one, all of these are all 3 different axes. Okay, let's just get that towards 0. So imagine, the z-axis as, if we were perfectly aligned, z-axis would be our distance from each other. If we were aligned kind of face to face, and x and y are the variables that allow us to line up face to face. So the biggest difference it looks like is our x. We're way away on x, so let's get closer there. And I want to make sure that this number is probably negative, right? It looks like in this case, so that I don't come in from the side and smash the solar panels. And you can kind of game each of these numbers individually or all at one. It really kind of depends on how you want to optimize or show off your skills. I usually try to kind of manipulate them all at once because you're trying to get all 3 numbers to align at the same time. Now, Navy Fish was a cool mod that I hope somebody revitalizes it, or maybe I'm just ignorant and it's still around and maybe I'm just not seeing it on CCAN. But it would give you a graphical way to line things up, and I never really adapted well to it. But with these numbers, one time I did use these numbers in MechJeb. Oh, and these aren't just regular numbers in MechJeb. You can, this is a custom MechJeb window. So your target, docking, guidance, position, and velocity. So that's where I got these from. It gives you all 3 of those. And if you go through all these MechJeb options, there are tons of displays and information you can get in MechJeb, like relative inclination, same thing. It's probably in that target menu as well. There's all kinds of useful bits of information that MechJeb has available at your fingertips if you only know quite where to look. So I'm closing that distance pretty well. So this is a good speed to me, I think. I'm going, usually faster than I usually do. Usually I'm at the 0.01, the really small units. Now, if these, so you recall, if you recall earlier in the video, using the RCS caused me to angle a bit. So if I had, it caused me to pitch. So there's translation and rotation. Those are 6 axes of control. So let's see. These are, I want around my center of mass so that when I try to translate, that's what I'm doing right now. I'm translating through 3D space. It doesn't also cause my spacecraft to pick up a rotation by a torque. So having these around the center of mass means that it won't cause it to rotate if these are if all of them push in one direction. It won't induce that rotation. So if I put these RCS ports lower, if I didn't put them around the center of mass, it would induce that rotation, which actually I did on one of my earlier attempts. I also had the wrong docking port. I had just the fuel one from my early more Gemini craft. Okay, so let's level that out at about 0. That's the number I'm watching. Some of the other ones have probably wandered off already. Yeah, looks like I wandered by the ideal location in Y. So I just want to get this at about around 0. And these numbers will move just a bit if you... So what I just did, I kind of reset the parallel, because this station is probably rotating a little bit, or we're moving around the Earth. So what's precisely parallel it seems to change with time, just a little bit. And these numbers will wander a little bit as well, because even though there's no obvious rotation that I'm getting, there's tiny rotations. So now that I'm kind of nearish 0, within 0.1 of 0, that's close enough. And then I can just more or less ignore that unless that wanders, past 0.1 or so, which it looks like it did somehow, even though this was, close. So I think I still have a little bit of a rotation being induced every time I make these adjustments. So I find this is definitely time consuming, docking like this, but it's, it's relaxing. You set up your music or whatever, you just have a save game where all you really do is need to do this rendezvous and docking. And it's a nice, little, modular mission to do. That's all you really have to do with the, for your KSP mission in that instance. But it's definitely a tricky thing to do, so it's certainly worth having a guide and practice. So say with the Saturn V, with the command module and the lunar module, it was substantially took less energy and time for them to dock because they came up together. So they were moving, in their same location, moving at very similar velocities before their docking. That means that you had to have a launcher that was capable of throwing both of them into orbit at the same time. So different challenges. Like if you wanted to try to send, do a Gemini mission to the moon, to get into a Gemini craft into orbit, or to bring like a small lander like the Langley lander, or a custom lander you build yourself, you'd need something almost on the scale of a Saturn V or a Saturn C3 to do that. Whereas I'm more interested in trying to do that with multiple launches. So I'd have like a Titan C3, much smaller craft than a Saturn, or a Saturn IB, or Saturn V, or a C3. Just find it interesting to launch those smaller craft. So these numbers are close-ish. You can see, so when X and Y are zeroed out, that's when our anti-parallel pointing is actually pointing us exactly at the target. So that's how I think of those. Well, that's pretty close now. Pretty close. And as things stand, we could probably, in Realism Overhaul, probably make the magnetic force even lower, because in reality, obviously, there is no magnetic force. You actually have to get the docking drogue into the position. In this case, there is no docking drogue, it's a docking ring, but you'd actually have to have the rings perfectly in position in order to dock. But for approachability, sometimes we have to balance true realism with playability, and so we still have some of the magnetic force even in Realism Overhaul for docking. So even if I move around, you can see we're still relatively well aligned and moving in at that 0.08. So I'm just going to turn everything off and let them couple to each other. So see, it's not perfectly aligned, but it was enough to get it close, and hopefully those clunk together happily. There we go. So you can definitely take your time more, like design your craft better, etc. Most of everything I design and fly is just a crash program. So let's see if it recognized. So see, it looks like the same problem I had before of this contract. Come on, where was it? Return the crew home. See, it didn't recognize me rendezvousing with the space station, this craft. So it looks like I still have the same bug with the contract. I'll have to check with Nathan Kell to see if, check the code, make sure I definitely have the right version, but this still might be a bugged contract for now. So, stay tuned. You'll see that in the RP-0 release notes at some point, if in fact we solve that problem. But for now, I'll leave these craft as they are. I successfully rendezvoused and docked them. Thank you for watching, and obviously the rest of this contract would be easy to complete. I've got these crew, so I just need to do the crew transfer, and then they'd need to spend 30 days up here. So if we look, the now combined craft has plenty of resources to keep everybody alive here. We've got plenty of solar panels as well to keep us in power. So it looks like, actually I could probably even turn off some of these craft as well, so we're drawing less power. But yeah, so this station, this first crew on my station here would be able to fill that contract once we work some small bugs out of the contract. And that will be really exciting, very interesting to have in RP-0, where you can, we have contracts such that you can get to complete a mission for landing humans on the moon and returning them. And now we'll start having these duration missions, which you could do. Gemini, for example, spent 2 weeks in orbit to prove that people could survive long enough to get to the moon and back. And then beyond that, the Soviet Salyut program and the American Skylab program. So those were the next step forward in human spaceflight. So we hope to have those contracts in RP-0 soon. So thanks again for watching. I hope you enjoyed. Hope you learned as much as I did, because I learned a ton. I learned that home and transfer works much more consistently when your craft's orbit is completely below the orbit of your target. So it's handy to have your target in a fairly high orbit like this, and then you start from a low orbit like 180 by 180 or 200 or so, and then do the home and transfer after it lines you up. Well, thanks for watching. Goodbye.